Hi, so today we're going to do trigonometric equations. And so our learning intention is to gain the knowledge of how to solve trigonometric equations. And we will be successful if we can provide the solution in radians or degrees, and if we can correctly balance the equations and use trigonometric identities to solve problems. Okay. Here's the first example. We want to solve each equation from 0 to 180 degrees. I've got 3 plus 2 sine x equals 5 sine of x. They're both in the same function, and so what I'm going to do is I'm just going to bring this 2 sine x to this side, and using my algebraic techniques, if I'm going to move it, I'm going to subtract 2 sine x from both sides. So 3 sine x minus 2 sine x is, 5 sine x minus 2 sine x is 3 sine x. I'm now going to divide by the coefficient of 3. So I get sine of x equals 1. Okay, so if I looked at my sine curve, and it's from 0 to 180, just a quick sketch. There's the sine curve. That's 360. So I'm only looking at this half of the curve. Where is sine x equal to 1? So I'm in degrees. So I need to make sure my calculator is in degrees. Currently it's in radians. So shift mode 3. So shift sine of 1, I get 90 degrees. So x is 90 degrees, which correlates to that point there. Okay. So you could either done with the graph, realizing that this was 180, so half of that is 90. Okay. Let's look at this one. We've got sine of x equals 2 cos of x. Unfortunately, we've got a sine and we've got a cos, and we can't do a lot about that. But why don't we manipulate this? And one way we could divide both sides by cos of x. And if I do that, well then this will become a constant of 2. Yeah. So sine of x divided by cos of x equals 2 cos of x divided by cos of x. Well, as I said, that just cancels each other out, so it leaves me 2. And using my identity, sine of x equals over cos of x is the same as tan of x. And now I want to find out what where tan of x equals 2. So that's the same as x equals tan negative shift tan of 2. Alright, so let's do the first part. So shift tan of 2. We'll do it to the nearest minute. So 63 degrees and 26 minutes. I'm only concerned between 0 and 180. So I'm only concerned in these quadrants at the top here. Tan is positive in the first quadrant, but negative in the second quadrant. So I've only get one solution. So x is 63 degrees and 26 minutes. Alright, so now we're going to solve for each equation from 0 to 360, so a full revolution. Now if we have 2 sine x equals tan of x, now what we want to do is kind of make them the both function, and unfortunately we can't at the moment because that's sine and that's tan. What we can do is if we move everything to one side, we get 2 sine of x minus tan of x is 0. We can rewrite tan of x as sine of x over cos of x. And what I can do now is I can actually factorize. I can take out the common factor of sine of x. And if I did that, that would give me 2 minus 1 over cos of x. And that equals 0. Now, in this situation, it's an equation, so I'm going to apply the null factor. So for this to be true, so sine of x multiplied by something to be 0, one of these things has to be equal to 0. So if that is either 0 or this is either 0. So, where is sine of x equals 0? Well, that it happens, we're in degrees, so that's going to happen at 0. If we look at the graph again, it's going to happen at 0, 360, and 180. So 0 degrees, 180 degrees, and 360 degrees. Okay. Now, let's look at this. So we've got 2 minus 1 over cos of x equals 0. So what I'll do is, in order to get rid of this fraction, I'm going to combine the numerator. So that's really 2 cos of x minus 1 over cos of x. And that has to equal 0. Well, if this is a situation, a number minus a number divided by a number is fine, as long as the denominator is not 0. So cos of x can't equal 0. So if that was the case, if as long as this is not 0, the denominator is not 0, we really get 2 cos of x minus 1. That equals 0. And so 2 cos x equals 1, and cos x equals a half. So where does cos x equal a half? Well, cos is positive in the first and fourth quadrants. Using our exact triangles, we've got 2, 1, square root 3. Cos is adjacent over hypotenuse, so it's this angle, which is 60 degrees. So we get x is 60, as well as 360 minus 60, which is 300. Sorry. So cos is equal to half, which is 1. Yep. Okay, so therefore, x includes 0, 60, 180, 300, and 360. Okay. Let's look at our second example. We get sine of x minus cos of x, and that equals 0. Okay. Once again, I want to just have one function, and unfortunately we have two. So what I can do in this case, I can go sine x, I'll bring that over here, equals cos x. Alright, if I divide both sides by cos, I'm going to get 1 on this side, and I'm going to change that into tan of x. So where does tan of x equals 1. Well, going through our quadrants again, tan is positive in the first quadrant and the third quadrant. Tan of 1 is 45. So x equals 45 degrees. And as well as 180 plus 45, so 225. Yeah. Cool. All right. So continuing on with the same questions, we've got solving each equation for 0, x is less than 0 but less than 300, greater than 0 but less than 360. We're going to solve for sec squared theta, and we need that to equal something. So let's say that equals 2. Okay. So what that says is that, well, sec theta, so to unsquare something, we take the square root, and so it's going to be plus or minus the square root of 2. So sec is basically 1 over cos x. Yeah. And so if cos x is adjacent over hypotenuse, sec x is hypotenuse over adjacent. Okay. So that means that we could write this as cos x is plus or minus 1 over root 2. And using our triangles, so we have so 45, or pi on 4, we're in degrees, so 45 degrees. Okay, so x, now it's positive or minus. So really, it's cos is positive in the first and fourth quadrant, but it's negative in the second and third quadrant. So we really want x equals 45, 180 minus 45, 180 plus 45, and 360 minus 45. So we get 45, 135, 225 degrees, and 315 degrees for that solution. Okay. All right, so now we're going to solve 2 sine 2x minus 1 equals 0 when x is between 0 and 360, so another full revolution. What I want you to notice is now this is 2x, which is different to just x. Okay, so it means that we're actually going to go, so if x is between 0 and 360, 2x is going to be between double that, so 720. Okay. Okay. So, sorry, we get 2 sine 2x minus 1. That's the same as 2 sine 2x equals 1, or sine 2x equals a half. Okay. So if we were going around once, so sine is positive in the first quadrant and the second quadrant. So when sine is a half, so opposite over hypotenuse, using our triangles again, we want this, so that's 30 degrees. So we get 2x equals 30 degrees. And it also equals 180 minus 30, which is, so that's 150. But it says we've got 2x, so we're going around twice. So imagine a full revolution, get to 360, so we get 360 plus 30. That's 390. And if we go 360 plus 180, that's full revolution to here, and then we're going to minus 30 again. Oh, sorry, minus 60, no, 30, sorry, gives us 510. Okay. Notice that I wrote 2x, and I've written 2x here. I now only want 1x. So that's 15 degrees, and what I'm doing is dividing this whole line by 2. Half of 150 is 75. That's 195. And 255. And that's the solution. Okay. So now we're going to solve sec squared 2x minus 2 tan 2x equals 0 for when x is greater than 0 but less than 2 pi. Once again, notice that this is 2x and here is just x. So we actually really want, if x is greater than 0 but less than 2 pi, if we want 2x, we're going to double it. So that's going to be 0, and that's going to be 4 pi. Okay, so once again, I've got a sec squared and I've got a tan. So they're not the same. So I've got to somehow manipulate it so that they become the same. Using the identity of sine squared theta plus cos squared theta equals 1, I could divide everything by cos squared. And the reason why I'd want to do that is because 1 over cos squared theta gives me sec squared theta. That becomes 1, and this becomes tan. Okay, well, I can replace this for this. So what I would get is I would get tan squared rather than theta will be 2x plus 1 minus 2 tan 2x, and that equals 0. I'm just going to rearrange this so we get the highest, like the powers in order. Okay, now if I let u be tan 2x, for example, what I get is I'd get u squared minus 2u plus 1. Okay, this is a quadratic, and we can easily factorize this to be u minus 1 all squared, and that equals 0. And if we wanted to solve that, well then u has to equal 1. But resubstituting back, u is actually tan 2x. Yeah. Okay, so tan 2x equals 1. Okay. We are going around the quadrants twice. So tan is positive in the first and third quadrant. And we're going to go around it twice. So tan of 1, so 2x, if we're in degrees is 45, but in radian is pi over 4. This here is pi plus pi on 4. We're going around it twice, so we really want 2 pi plus pi on 4. That's 2 pi. This is 3 pi plus pi on 4. So working that out, we get pi on 4. This becomes 5 pi on 4. That becomes 9 pi on 4. And this will become 13 pi on 4. That is 2x though. So if I wanted just 1x, I'll divide everything by 2. Dividing by 2 is the same as multiplying by a half. So it becomes pi on 8, 5 pi on 8, 9 pi on 8, and 13 pi on 8. And that's the solution. Okay, so we've got sine squared theta plus cos theta minus 1 equals 0. Once again, there's some issues. I don't really have anything in order of the same function. So I and I've got a squared. So what kind of want to manipulate something. What I do know is that sine squared theta plus cos squared theta equals 1. And so what I'm going to do is I'm going to substitute this for this value of 1. So what I would get is sine squared theta plus cos theta minus this, sine squared theta plus cos squared theta. Alright, that equals to 0. This is actually quite good because I've got sine squared theta, and if I expand that, it's negative sine, so that cancels each other's out. So what I get is I get cos theta minus cos squared theta, and that equals to 0. I can factor out a cos theta. That's nice. Oh, sorry, that will just be cos theta, not squared. And that equals 0. So once again, applying the null factor. This will need to be cos theta equals 0. And it equals 0 here and here. So I'm in radians. So theta at this case would be pi on 2 and 3 pi on 2. Shift cos 0. Yep. And this would be 1 minus cos theta equals 0. So cos theta equals 1. So I get theta equals 0, of course, and 2 pi. Okay, so really, when we summarize everything, theta goes from 0, pi on 2, 3 pi on 2, and 2 pi. Okay. Looking at the next example, we got 6 tan and 5 cosec. Once again, we've got a tan and a cosec, so that doesn't really help us. We need to kind of manipulate it so that we get the same. So, if I change this into terms of sine of cos, we get sine x cos x. I'll bring that over here, so that's going to be minus 5. I'll convert that into terms of sine. That's going to be 1, which is just multiplied by 5, or multiply of sine x, and that's going to equal to 0. Alright, let's multiply the tops and combine the bottoms. So we get 6 sine squared x minus 5 cos x. And that's going to be all over sine x cos x. Okay, and if that's the case, well then sine x cos x can't, the product of them can't actually equal 0. Yeah, because you can't divide by a 0 number. Okay, so really we get 6 sine squared x minus 5 cos x equaling to 0. What I might want to do here is I probably want to square everything off. So I'm going to square everything. So I get 36 sine cot x minus 25 cos squared x is 0 squared. Okay. Unfortunately, there's still got sines and we've got coses, but knowing that we've got cos squared x plus sine squared x equals 1, cos squared x would be the same as 1 minus sine squared x. So I'm going to replace this for that. So we're going to have 36 sine cot x minus 25 lots of 1 minus sine squared x, and that equals to 0. Expanding this out, we get 36 sine cot x, and I'm going to try to do it so that it decreases in degrees. So the next one will be that. So negative 25 times that becomes positive 25 sine squared x, and then minus 25 equals 0. So let's just let, once again, u be sine squared x for the time being. So that's going to basically be 36u plus u squared plus 25u minus 25 equals 0. And using our quadratic formula, we can get minus 25 plus or minus the square root of 25 squared minus 4 lots of 36 minus 25 all over 2 lots of 36. Let's let's just see what that might be. Minus 25 plus square root 25 squared minus 4 lots of 36. 2 lots of 36. I get 5 over 9. If I change that to a negative subtraction, I get negative 5 over 4. Okay. That's really nice. So we can remember to substitute back. So we actually get sine squared of x equals that, or that. So let me write that down. So we've got sine squared of x equals 5 over 9. So to unsquare that, we get sine x is plus or minus the square root of 5 over 9. Now this one is negative 5 over 4, and we can just ignore this because when you take a square root of a negative, at the moment we can't do that, so that goes away. So we're only really looking at this situation. So using our calculator, what is inverse sine of positive root 5 over 9? I am in radians, so let's just do it to 2 decimal places. So we get 0.84, and okay. So, and we also want the negative. Yeah. So negative. Okay. All right. So thinking about this, we have sine being positive in the first and second quadrant, but we have sine being negative in the third and fourth quadrant. So what we're going to have is we're going to have this value, which is in the first quadrant. We're going to have pi minus this value. We're going to have pi plus that value, and then 2 pi minus that value. Okay. So using our calculator, so if we have, I'm just going to save that. So we've got pi plus that value, 3.98. Sorry, that should go here. Um, 2 pi minus 0.84. We get 5.44, and pi minus 0.84, we get 2.30. And that's the answer for that problem. I may start this on a different sheet, so I'm going to do C7 sine of x cos of x plus cos squared of x equals 1. And we're going to go from 0 through to 2 pi. Let's bring everything to one side. We get 7 sine of x cos of x plus cos squared of x minus 1. That equals 0. Well, as before, if we know that sine squared of x plus cos of x squared of x equals 1, then sine would be 1 minus cos of x. But unfortunately, we want cos squared x minus 1. So if I times that by negative, that becomes a positive. and this becomes a negative. And that's what we want. So we really have 7 sine x cos x minus sine squared of x equals 0. If I take out a factor of sine, I get 7 cos x minus sine x, and that would equal 0. Okay, so applying the null factor, sine x equals 0. We're in radians. Remember that knowing our graph, it happens here and here. So x is, and here. So we've got 0, pi, and 2 pi. Now, doing this one, we get 7 cos x minus sine of x equals 0. So we've got 7 cos x equals, take this to this side, it becomes positive sine x. Okay, if we divide everything by sine of x, well, this becomes 1, and this becomes cot of x. So cot of x is 1/7. Now, that's the same as saying tan of x. So remember, cot is adjacent over hypotenuse. And it's the inverse of tan, and tan is the adjacent over opposite is cot, and tan is opposite over adjacent. So we want tan 7. Using our calculator, we're in radians, shift tan 7, we get 1.42, we'll do the decimal, so 1.43. Okay. But we also want, that's the first quadrant, but we also want the third quadrant, which is pi plus that. So we also want pi plus 1.43, so plus pi gives us 4.57. So x, putting them in order, we get 0, we get 1.43, we get pi, we get 4.57, and we also get 2 pi. Okay. Alright, last example, we want to solve the equation of cosec squared x minus 2 cot x equals 4. Okay. Once again, I'm going to go from negative pi this time to 2 pi. Okay. So if we had sine squared x plus cos squared x equals 1, I want a cosec, so I'm going to divide everything by sine squared x. That's going to give me 1 plus cot. So I'm going to replace that. So we've got 1 plus cot squared x minus 2 cot x equals 4. Rearrange that, we get cot squared x minus 2 cot x. That's 1. I'm going to bring that 4 to this side. That's going to take it to negative 3. Yeah. So if we let u equal cot x, we get u squared minus 2u minus 3. Factorizing that, you get u minus 3u plus 1. Substituting back, you get cot x minus 3 cot x plus 1. Applying the null factors, we get cot x equal to 3, and we get cot x equals to negative 1. Okay. That is the same, so cot x equaling the 3 is the same as tan x equaling a third. And this would be the same as tan x equaling negative 1 still. Okay. Cot is positive here and here, and tan is negative here and here. Okay. So shift tan, oh we got 1 over 3, no. Yeah. So 2 decimal places, let's go. X is 0.32 and pi plus 0.32. So we get 0.32 and 3.46. Alright. So tan, we got negative 1. So tan of 1 is 45, so we get, or pi on 4. So here we get pi plus, sorry, minus pi on 4. We get 2 pi minus pi on 4. Okay, so we would actually get 4 minus, that's 3 pi on 4, times, that's 8, 7 pi on 4. Okay, so that's from 0 to 2 pi. Okay, but now we're going to go back 1 pi, so we're going to go backwards. So looking at this, where is tan positive? So if we're going that way, we get, here we get 0 minus theta, and here we get negative pi so it'll be negative pi minus theta. Here would be plus theta. So we've got negative pi minus, so negative pi plus 0.32. We get negative 2.82. And going here, if we're going back to negative pi, we've got 0 minus, so we've got minus pi on 4. So putting it all together, we get negative 2.82, negative pi on 4, 0.32, 3 pi on 4, 3.46, and 7 pi on 4. And that's our final solution. Okay, thank you very much.